Welcome back. Just setting up here to do some spiral milling for the cutter grinder project. This is kind of loosely based on the Quorn design, which has a helical slot milled in the center spindle that the grinding head moves up and down on. It's not critical. Its purpose in life is really just to make sure that the work head, when you try and adjust its height, doesn't just slip way down to the bottom. It's usually manufactured on the lathe as a very coarse pitch screw, but A, the shaft doesn't fit in my lathe because it's too big, and B, that's a bonkers thing to do when you've got a setup here that will do spiral milling. Just noticed a little ding in there. I don't remember doing that. It's really annoying. This is a piece of precision ground silver steel from Coventry Grinders. It's, apart from that little ding, it's really rather, yeah, I'm gutted about that, but never mind, it'll buff out. A precision ground piece of silver steel from Coventry Grinders, and I've just set the milling machine up to do a spiral milling operation. Now, the reason you'd normally do spiral milling would be to produce helical gears and stuff like that. I will do some of that, but for the moment all I'm going to do is actually use a little end mill to mill a little slot in here. It'll be a 4mm end mill. We'll mill a nice little slot in there. It's going to be left-handed because that's how my setup ended up, and I can't be bothered to manufacture a spigot to reverse the direction. Let's not get into the gearing yet, we'll cover that in a second. This is set up, I've got this squared up just with a dial indicator, so if I move the table, we're kind of within a few thou over the entire length. And that's the same in up and down. That's achieved just by usual method of set it up, indicate it, bump it around a little, lock it down, and perfect. Little cap on the end here. These are centerless ground rods, and again, it's too big to fit in my lathe, so I couldn't just clock it in, set it up and do a marker center hole, which would have been convenient. I will get a bigger lathe at some point, but you know, it's difficult at the moment. This will do. So this is just a little cap. It's a snug press fit over there. There's a ball bearing in there and a little divot, and that just butts up against, provides a bit of bearing surface because the end of that wasn't cut off in a precision fashion. Just makes it quite nice and easy. So yeah, it's quite a rigid setup. You can see I'm heaving on it quite a lot there, and I'm only getting a few thous deviation. Quite happy with that, and it returns to where it should be. So cutting forces, nice sharp carbide end mill, only 4mm wide, nice steady cut. It's going to be easy, no problem there with the rigidity at all. The dividing head is carved out the solid. It's quite a lift. Let's just set this back up. I've configured this so I can actually still move the table around, because as you can see, it's quite... Move the table slightly, knock the power feed off just so I can't do that accidentally. It takes a bit more thought than just doing it. Right, re-engage those. This is the opposite of how you'd normally have these gears arranged for doing helical milling, because you'd not normally have a helical gear with a helix angle of sort of 80 degrees, which is what we're going to end up with. So I can't drive this with the table power feed. That's a 13.3 recurring to 1 gear up there, which, yeah, it seems a bit crazy, doesn't it? I haven't actually got those meshed either. Just sort that out. That looks better. Much better. Okay. Wonderful. Oh, I've got a second collar to put in there. That's why it's looking a little slidey. That's okay. We'll sort that out in a minute. It will work. It is keyed. So, the fundamentals of this are that you rotate the work while you move the table, which is achieved by, got that unlocked. I'm going to drive it from this end, like I said, because if I use the table power feed, 13.33 to 1 increase, it ain't going to like that very much. So inside there, we're actually going to turn the plate, which has a set of helical transfer gears which turn this auxiliary shaft here. You'd normally use this for either spiral milling or differential dividing with the attachment that fits in the end, something like that, and you can put another gear on there so you can rotate the auxiliary input as the head rotates and do differential dividing. Well, I'll do a video on that at some point because it's pretty cool. It's quite an interesting thing, but remove that for the moment, so we don't need that. So basically it works like this. I rotate the handle here, and it might be helpful if we put a little mark or something on the right, let's put a little mark on. There we go. A bit easier to see now. It rotates away. Moving the table feed, and at some point in the not too distant future, there's our mark. Cool, huh? So that's our lead. It's 16 mil. Sorry, no, 15 mil lead this gives with the gearing we've got. I'll put the calculations somewhere because it's quite interesting calculating this. That's basically it. The spindle's not in the right location yet. I need to indicate that end, set my end mill up, and I'll show you in a minute. I'll put the Sharpie in and I'll run down the length here just as a test cut without actually cutting anything, and we can draw a nice spiral on with the Sharpie. That would be pretty cool. Let me set that up and do that, and you can see it in action. What, you never put a Sharpie in an ER32 collet? Touch off. Things locked up. Going the wrong way, but cool, huh? That's going to be interesting. Just managed to slip the thing out of there. There we go. I'm going to have to rig up a motor for this. And so on. You get the idea. My arm is going to be knackered. That was a lot of rotating that handle, and it's driving all of this and the table. It takes a bit of power to drive as well, so no wonder the poor old power feed won't do it. Anyway, in case you're wondering what the bits of paper in there are, it's just to square this up in this old 3-jaw. It's seen better days. I need to arrange something better for it really, but it does work. I guess I better take the cut, hadn't I? Alright, we're set up here to do the cut. I've got, off camera, I've just drilled a little hole in there just to start, because I don't want to plunge with that tiny end mill. It's a 4 flute, 3 flute would have been quite nice here, but I don't have one. It's not a ball nose, it's just got slightly chamfered edges, so it leaves quite a nice sort of corner around the bottom. APT, I think that came from. Choked up on it pretty well in there. As you can see, I ran the spiral all down with the pen. It all checks out perfect. Just to check that I could get all the way down, no interruptions, no problems. we've got the dividing head set up, all the gears there. I was looking at setting a motor to drive this up, that's why this extra gear's here, but I can't be bothered to faff about with this one. I just need the job done, because until I get this off here I can't really use the mill. Well, I could use the corner here I suppose, but yeah, whatever. Anyway, I think it is time. Well, that's how we got from a nice piece of ground silver steel bar to a piece of silver steel bar with a helix milled in it. To get there was actually a fair amount of setup. I suppose the biggest job really is cutting the gears. They had to be fairly large because they needed quite a decent ratio, and actually bridging the gap between the auxiliary input of the dividing head and the table lead screw is quite a way. Couldn't do these on the lathe. Had to be done on the blanks had to be cut on the rotary table there. Another little job was making a bushing, because the table lead screw is smaller than the diameter that the dividing head takes on its gear input, so just had to make a little bushing there and do some broaching for woodruff keys and keyways and such like. There's the result. Just checking for fit and such like, and eventually we end up with the compound train just like this. So I made myself a little Excel sheet to calculate the gear ratio here. I'll just go through the calculations quickly. Just got a 40:1 dividing head, which is pretty standard. Metric mill, 5 mil table movement per handle rotation, so 5 mil lead there. Few important things here. It's a little different, the nomenclature for either helicals or cutting a spiral. The helical would be cut on the pitch circle diameter, not the outside diameter, whereas we're just working at the outside diameter of the bar here. This calculation will work just as well for a helical or a spiral of any kind. So there's two calculations here. One you can actually calculate based on wanting a given helix angle. It's not that useful, as you'll see in a moment. The calculation over here actually is based on the lead you want to achieve, and then derives the helix angle from that. So just to run through it here, the tan helix angle was just an intermediate calculation. It was just easier to separate that out because it made the Excel formula a little bit easier to read. So if we go through here, we've got 32mm piece of bar. We want to derive everything from that outside diameter. Here I've just chosen a helix angle of 81.5 because it arrives at about the lead that I wanted to achieve. So this calculation here, Excel obviously wants everything in radians, so you've got to do the intermediate conversion here. So you just take that the tangent of that helix angle there, and then it gets plugged in down here. So we've got the PCD times pi over tan helix angle, which has already obviously been calculated there. So there's the actual formula there. So with a helix angle of 81.5 degrees, that's what we get as a lead, which it's not it's not ideal. It's close, but it's not quite. Down here, this is where your mill specifications come into play. So we've just got a quick calculation here based on the desired lead that we want out of our helix, and the dividing head ratio and the mill lead screw, and then we just take the reciprocal of that to get a kind of a sane looking gear ratio rather than something you're not used to looking at. So that's 13.3 something to 1. We look over here, similar kind of calculation here, is just derived from different things. So here we've specified a 15mm lead, and we've got the intermediate calculation there is kind of similar to over here, although slightly different. It'll explain just over here exactly what that's doing there, and then we derive our helix angle from whatever the lead is, so that's something off 81.5 degrees. Here we use the I think it's the inverse tangent atan. Pops out with a calculation there. So 13.3 recurring is actually relatively easy to achieve, much as it's an irrational number as a gear ratio. That's actually I've got a little thing here which I used to calculate based on what gears I had available in a compound train. I won't go through that though, you can find that information somewhere else. So there's the calculations. Nothing terribly complicated there, and this would work perfectly well for imperial measures as well. Just take take it in thous or inches, whatever you want to do really, it doesn't matter, it will still work. So yeah, there's the calculation. Can be found in Machinery's Handbook, although I think I found that slightly obtuse and found it online from somewhere else. But there you go. Any questions, just pop them in the comments. I'll try and get back to people. I don't think this is a particularly well covered topic on YouTube. A couple of videos on differential dividing and a few things you'll see people with setups like this, but I don't think I've seen anybody actually put the calculations down. So hopefully somebody finds that helpful anyway. Like I say, any questions, just bung them in the comments. Thanks for watching. I'm aware this is kind of a long video, and it's been ages since I've actually uploaded anything. Thanks to all the new subscribers that have been just randomly appearing over the last, I don't know, year or so. If you're interested in more content like this, I'm not going to post every little machining job I do, but the things that are a little bit further out there and sort of not so well covered, I'm kind of interested in doing. So give me a thumbs up if you liked it, and if you want to see more. Thanks for watching. Hopefully see you again. Cheers.